What's going on, guys? It's Mr. Jones once again. Today, we're finally going to get into the Integrated Math 2 book. I say finally, it's only been a week, right? But we're going to go ahead and get into some Integrated Math 2 stuff. So you'll notice on the screen that it says 1.1, something to talk about. So this is the very first chapter, the very first task in the Integrated Math 2 book. So also I want to take your attention right below that to where it says a develop understanding task. So whenever you see a develop understanding task, go ahead and underline that. That legitimately means it's going to be difficult. It's going to be something new, and you're probably not going to walk away from this feeling like you learned a whole bunch of stuff. Okay, we're going to take this stuff and all this thinking and we're going to learn from it and we're going to learn a whole bunch of new things. But please, what I usually ask my students in class is bear with me, trust the process, and just know that you're probably going to get frustrated and it's okay because it's expected in this task. So, without further ado, remember the things that we did with arithmetic and geometric sequences, right? We made tables, we looked for the pattern. So you guys did a lot of that last year. We're going to do that this year, and that's why I wanted you to practice that with some stuff that you should have been a little bit more familiar with. So use those skills today. So I'm going to go ahead and read the scenario. Cell phones often indicate the strength of the phone signal with a series of bars. The logo below shows how this might look for various levels of service. So you can see figure 1, figure 2, figure 3, figure 4, and it looks like cell phone bars or stairs or something like that. So however you see it could be different than someone else, but you can see the figures are changing. So the very first question, of course, you've heard this one a couple times now. Assuming the pattern continues, draw the next figure in the sequence. Go ahead and do that. Okay, now that you've had a chance to do it, you can see what I drew. My drawing obviously looks pretty bad, but it does the trick, right? So hopefully you guys have something very similar on your paper. And then the next question is going to be, how many blocks will be in figure 10? And also, we're going to be looking for an equation if you can figure one out. We're not going to stress the equation too much. We're going to stress the table a whole lot. So I'd really like you to get a good table and see if you can figure out what the pattern is and what's going on in the sequence. So right now, go ahead and take time and draw a table. All right, so now that you guys have had a chance to make a table, I drew a table. I know my table looks a little bit funky, but you'll see why here in a little bit. Hopefully you guys tried to find the pattern and tried to figure out what the heck was going on. And maybe you got frustrated, and if you did, that's actually a good thing because that means that you were really digging in. So I think the first thing I always check is to see if it's arithmetic. So we learned that it wasn't arithmetic because we're not adding by the same thing every single time. The first time you're adding by 2, and then you're adding by 3, and then you're adding by 4. So then we also learned it wasn't geometric because in the beginning you'd be multiplying by 3, but if you multiplied 3 times 3, you would get 9. And so we know it's not geometric. So there's something else going on. So we're going to learn about polynomials soon. And so this is going to be kind of helpful and fit with all polynomials. So here we go. The first thing we're going to do is we're going to find the difference between 1 and 3. So what do we have to add by to get from 1 to 3? 2, right? 1 plus 2 is 3. 3 plus what is 6? Okay, so 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And hopefully you can see a pattern in the blue. So my original sequence is, of course, in the black and red. And we're going to call over here in the blue. Okay, the blue is my first difference. It's called our first difference. First difference. Okay? So normally our first difference, if it's arithmetic, is the same number over and over and over. We write over there on the side like plus 2, plus 2, plus 2, plus 2 or whatever. But that's not happening. So our first difference is here. It goes 2, 3, 4, 5. And I'm sure you can figure out that this one would be a plus 1, right? All right, so now we're going to go out to the second difference, and this is new, so I'm going to use orange, my new color, Woodlake orange. All right, second difference. So now you say 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4 plus 1 is 5. See, so now you can see that the second difference is 1. Okay. With all that being said, I'm going to spare you the drama of learning how to do the recursive formula because students always hate it, and I've never seen it worried about in any higher math anyway. So I'm just going to show you the whole point of this table and why we made this table, okay? This first difference here, the blue, this is linear. This second difference, constant. Constant means it's the same number every single time. So look at the blue. Pretend the blue was your sequence. 1, 2, 3, 4, 5. If that was my original sequence, you can see that it'd be adding by 1 every single time to get to the same number, which is what my orange is, right? So if my blue was my original sequence, my orange would be my constant difference, right? Or my common difference, whatever you want to call it. So the blue is linear. Now, if you go one step further, the red, that has to have a name. So we know that if it has a constant difference like the orange, then it must be linear because that's arithmetic. Linear and arithmetic are the exact same thing, right? Arithmetic sequence, they have the same thing added every time. They have a constant difference, okay? But one step further than that, if your first difference is linear and your second difference is constant, now you have this new one, and it's called a quadratic, okay? So in the previous assignment that we did within the past week where you had all these tables and you had to describe, how did you know that it wasn't linear or exponential? How did you know that it was this different function? You're supposed to say because the first difference is linear and the second difference is constant. So we have a new term. It's quadratic. It is a polynomial. It is a polynomial. Okay. And the way you know that it's a quadratic is because the first difference is linear and the second difference is constant. Okay. The way you know something is linear is because it adds the same thing every time. Its first difference is constant. And the way you know something's exponential, aka geometric, is because you're multiplying by the same thing every time. All right, make sure this gets in your notes, guys. I know this is really confusing right now, but we'll talk about this again. Okay, so just go ahead and get this in your notes and submit them.